and welcome to a new tutorial for OpenComputers. Today we want to discuss the changes and new features that came into the mod since the version 1.1. So basically it's about the versions 1.2 and 1.3, which is, when I'm not mistaken, currently in the pre-release phase. And I'm here with Keta, or Sanga, who is basically, the guy who did everything, So
hello. So basically we will capture most of the changes in 1.2 and 1.3. So 1.2 wasn't that much, but 1.3 was a pretty big update. And one of the biggest things is if you had a computer before, so like your basic build of computer case, a screen, a keyboard, and whatever you need. And if you try to turn it on now, you get an error. It will tell you that there is no bootable medium. So what this means is earlier there was this built-in read-only memory which contained the operating system, and that's gone. So now you need a floppy disk with the operating system on it. And you can craft that basically just using a disk and a book. So simple enough. And if you put that into a disk drive, now you can start your computer. So the reason for this was mostly to allow people to build their own operating systems much more easily than before, because, well, before you were forced to use the basic built-in one. Now you just have a very, very basic level of code that's given to you, and everything else is customizable, which is nice. So this also means that you can now just copy the operating system onto a writable medium. So if you remember from before, you see that the root directory is read-only. So if I try to do something like, I don't know, test, it'll tell me that the file system is read-only. So I can't just go ahead and write files to the root directory. So if I go ahead and insert a disk drive into the computer now, and then start the install program, it asks me where to install the operating system, and the 39D is the address of the disk drive. And I say, yeah, please install it to this disk drive. And then it starts copying the files over, and that takes a little time and makes a lot of noise. And when it's done, it asks you to reboot. And if you do reboot, you'll see that now the root directory is, in fact, the hard disk drive. So behind the covers, basically,
that's the OpenOS mount 135, right? Or
the 135 is the disk. So this is the read-only flag. So the RO means read-only, and that's still the floppy disk. But that's only in the mount folder now, and the hard drive is mounted to the root directory. So the topmost entry.
So the here. Mm-hmm. Okay. I was a bit irritated by the OpenOS, but that's...
that's just the name, the label of the disk, Okay. So if I take it out, I can just remove it from the disk drive and run the command again, then we'll see there's... Oh, the temp.fs is gone.
Okay.
Bugs abound. Anyway. So if I go ahead and try to edit tests now, it works, and I can just save it and can see that it saved it. So that's that. How this works is basically that there's one new callback in the API, which allows the computer to remember from which address to try and boot primarily. So if you start your computer the first time and there are multiple file systems in it with that are bootable, and bootable basically just means there's a file on it which is called init.lua. So this is just the file that's run from the kernel. If you have multiple file systems with such a file, it'll pick one at random, but from that point on, it will continue to use that file system. And you can change which one to use via an API call. So that's that.
Okay.
Any further questions?
Very nice. I hope not. But I sadly can't predict everything.
Yeah, we'll see. So that's the basics. So it's pretty simple to get your computer running again. Just slap down a disk drive and put a operating system floppy in it, and you're good. Right. So that's the one That's the biggest change basically in 1.3. The other big change in 1.3 is the change to how the robots are built.
Okay.
So before, you basically had your robot recipe in your item list, and that was it. As you may see here, there's no robot in my item list in any eye. That's because the whole assembly process changed a lot. There's now a new block, which for now is called the Robot Assembler, and that's what's used now to basically configure your robots, which allows a lot more flexibility in how you build them. So you'll see this is the basic GUI, and it asks you to insert a computer case to get started. So I have a little bit of stuff lying around here, which I'm going to grab. So you can build your computers from the 3 tiers of cases, 4 actually if you count creative. And if I insert this here, then I'll see a whole lot of more options now. And to the right you see it's basically like your standard computer case, and to the left there's a bunch more slots, and these are upgrade slots. So if you remember from before, you had your 4 inventory slots below the actual inventory of the robot, where the tool went, the upgrade went, a card went, and what was the last one? I can't remember. The disk, right, floppy disk. And these are basically these 3 slots below here, and these are containers for upgrades. So we'll get through that in a minute. And the ones above are just your common upgrade slots, so like navigation upgrade and crafting upgrade and whatnot. So that's that. To get your basic computer running, robot running, you have to build it up like any computer. So if I look here, it tells me I should insert a CPU. So I do that. Now it asks me for some RAM. I insert some RAM. And then you'll see there's this information for the complexity. So based on the tier of the case you insert into the assembler, you have a different maximum complexity of the robot that you can build. So if I go ahead and give me a tier 1 case and insert that, you'll see, oh, it only can take up to complexity of 12 and has a lot fewer slots even. And tier 3 has a lot more. So this basically is the base level of the complexity of your robot you can build. If I hold the assemble button, so basically the button that tells it to get started with building the robot, which will take some time and some energy, it tells me that there are a few components missing which I might want to add to get something that's workable. So if I just assemble it right now, it will be basically useless to me. So the most important thing is really a bootable medium, so I'll put in the operating system here. And the other things are, as usual, your keyboard and your screen. So important note, only tier 1 screens work. Tier 2 and 3 screens do not work. You will have to use a tier 1 screen. So I put these in. If you don't put these in, you will actually get a headless robot. So if you open the GUI of a robot that does not have a screen, the GUI will actually look different. You won't see a screen even.
What happens if I don't put in a OpenOS?
It just won't boot.
Okay. So could I later on put in a a floppy disk with the...
yes, if you build it accordingly. So
okay.
Let's jump a bit ahead to the containers here. Containers are basically hot swappable slots for the assembled robot. So there's a bunch new, I'll just give me those here for a moment. These new items, which are called containers. So there's card and upgrade containers in 3 different tiers. And I can put these in here. So these are the container slots. So if I put, let's say, tier 1 container in here, this means that in the assembled robot, there will be 1 slot for a tier 1 upgrade that can be exchanged on the go, so whenever you want. Okay. It will not be fixed in the robot like the upgrades in the upper part here. The upgrades in the upper part, they are fixed inside the robot. You cannot remove those. And one.
So basically, you're saying, okay, here I want to have an USB plug.
Something along those lines, yes, a hot swappable device, yeah. And the one container that may be not so obvious is the disk drive, actually. So you can put a disk drive in the container slot here. And what this basically means is that you can later on then put a floppy disk in there. So if you don't have an OpenOS disk in your robot or a hard disk drive with the operating system on it, you can then later on put a floppy disk into the robot if you have the disk drive in it. If not, well, then you're screwed and your robot is basically useless. Okay, so one more thing. Oh, right, graphics card. I love these warnings. Graphics card. Let's put in a graphics card. I forgot that one. Is the inventory upgrade. So, per default, robots do not even have an inventory now. So if I build this like this, the robot does not have any internal storage for items. So if I go ahead and break blocks, the blocks will just drop. It will not collect them. What I can do is this new upgrade here, the inventory upgrade. I can install those in the robot, and then it will have an inventory. And you can even install multiple inventory upgrades. So one inventory upgrade, it's not saying it in the tooltip, okay. One inventory upgrade provides 16 inventory slots, and you can have a robot with up to 64 inventory slots. So more than 4 inventory upgrades make no sense. There's no difference. Okay, yeah, one final note, exactly, the complexity itself. So how is this computed? It's basically based on the tier of the items that you use. So this is pretty much all tier 1, yeah. So these are 8 items, which is complexity 8, and then I have 2 containers, and containers are counted twice. So these are 2 basic ones, so tier 1, but times 2, and 2 of them, so 4, so we see complexity 12. That's basically how it's computed. So, and now I could go ahead and build this, but that will take some time, which we don't have. So I'll slap in a creative case, because with creative cases it will just complete instantly. So I built that, and now I have my robot. And it has some internal energy now, and this is not because it's a creative robot, but this is just the way it is. So if you assemble your robot for the first time, it will also be charged. Good, let's place this somewhere. Ta-da! So, we have a robot with a GUI and an inventory, and we can scroll in the inventory. So these are the 16 inventory slots. And that's that. It should start. Yes, it does. Right, and as we can see, the 2 upgrades the containers we installed are also present on the lower right. So we have the floppy from the disk drive and the upgrade from the upgrade container. And one remaining which is unusable because we didn't install anything in it. Good. Anything else? Did I forget something?
I can't think of anything. So basically, I think it's clear. It's a very nice feature because you can basically do whatever you like with your robots.
Yeah. So you have a lot more freedom and basically what you want to use them for. So maybe I could just, for demonstration purposes, build one. CPU. Where's the CPU? Where's the CPU? Without a screen. So if I place this one down, it has no screen. And it has no inventory. And it has no upgrade slots. So yeah.
But you have a robot which has energy.
Yep, and a tool slot. So you can basically build very specialized, very low-cost robots which will do exactly what they're told. So just have a disk drive in it with some startup program which will then automatically run whatever task they are designed for. That's the idea anyway.
I think it's very nice that this one without screen and everything is called Terminator.
It's a nice coincidence. Yeah.
Okay.
So, moving on, if you do build a robot which is utterly, completely useless and you basically would just dump into lava, let's build one. It takes 1 minute. There's a new block in 1.3 which is the Disassembler. So this block basically takes any item in OpenComputers, I think any item, pretty much any item, and will basically extract the components from which it was originally built. So There is a slight chance that one of the ingredients breaks, so just keep that in mind. But let's say I take something simple, a microchip. So the microchip consists of a few nuggets and some redstone and transistor, and whoops, if I throw that in there, it'll vanish, and then it'll get started and start basically extracting the original ingredients. So if you build a robot which is useless to you, you can just put it in here and get your original components back out and try again. Just keep in mind, parts may break, so only do it if you have to, or really don't need it anymore. Right, pretty simple. Alright, and it will dump any items it generates into an adjacent inventory. So if this chest, this was originally the graphics card, if this chest weren't here, it would just spit out the items into the world. So you will probably want to have an item next to it, inventory next to it.
In the case of 2 receipts available, what would happen? So if theoretically
example?
That a microchip would have 2 shaped receipts that, for example, because of or dictionary or something.
Ah, okay, right, for dictionary parts. Yeah, it will just take the first one it finds. So it may indeed happen that you get a different item. So, for example, if you have something which takes a piston, and it could be a sticky piston and a normal piston, you may get something else out than you put in. So if you crafted it with a sticky piston, it may be that you get a piston out. This can happen, yes.
Okay.
But most of these cases should not be dramatic. If they are, please let me know so I can fix it. Okay. This and this one. Oh, this
okay,
one's
the
done.
first iron nugget is already there, so it doesn't make
yes.
it.
No, it goes.
All at once, but over time.
Yes, exactly. So it goes item by item. Basically, if this bar has run through completely, then all of the items have been extracted, and it would be nice to have some sort of marker for every item that's being pulled out, but, well, you just have to imagine that. So it were originally 7 items, so every 7th of this bar you will see a new item drop in this chest.
So you can't really stop the process once it started? Okay.
Well, you can break the block, but then everything is lost.
Yeah, okay.
Yeah.
So basically this is a trash can which gives you back your
trash can
ingredients.
With benefits, yes.
But yeah, be careful.
Exactly. Well, it looks aggressive enough, no?
Yeah, right. No, yes. When it just stood there, not so much.
Yeah, true. But that's where the rest of the warning, in the GUI, this yellow tape, so beware, danger.
Okay.
Right. Okay, so since we're talking about blocks, one more block that's new in 1.3 is over here. This is the Geolyzer block, which is basically just a tool for measuring the hardness of blocks in its vicinity. So this can be used as a component that can be used by computers, and they can query the hardness of blocks relative to this Geolyzer block. And this is very useful. Well, it can be useful for finding interesting locations in the earth. So if you're looking for ores, maybe, I don't know, diamonds, anything, which are definitely harder than the blocks around them, it can be useful to find those. But it's also very useful to get a snapshot of the environment, so the terrain, and just plot that to another block, which is new since 1.2, and has gotten a tier 2 since 1.3, which is the Hologram Projector. So this is, well, it's not really a screen, but it's a block which can emit a hologram, so to speak, which consists of voxels, and you can actually set each voxel individually, so each 3D pixel, if you will.
Voxels in Minecraft, what treachery!
Yeah, where did this come from? Surprise! The creativity, I can't believe it. Yeah, so the tier 2 projector, which is new in 1.3, actually has tree color. So the old one in 1.2 had only one color, and the G2 one actually has more colors. It has the same resolution, but it has more colors, and you can write funny programs with this. So just to have a quick look into this one. If it were still there. Why is it not still there? Oh, right, it is still there, but it has an extension. There we go. So the component name is just Geolyzer, and the hologram is the hologram, and we can then call the scan method, which takes two parameters, the relative x and the relative z coordinate to the block, the Geolyzer block. And what we get back is a table, which is the hardness of the blocks in that column. So basically it's I think 64 entries, so 32 up, 32 down, which contains the hardness value of these blocks with a little bit of noise, so that it's not too easy. And well, this can then be plotted to a hologram. So if we run this, it should not break, and it doesn't break. And it starts happily scanning column after column and basically printing these to the hologram projector. So this red area here, red in this program, green is like the default hardness block, transparent is air, red is something harder, and blue is water or fluids. I don't know if there's any water. There's water. We might get some of that. So this red area here is basically this platform we are standing on, so all the iron blocks, which are harder than the dirt around them. And these are the computers and the other blocks. And yeah, we can just wait for this to run. And talk about other new stuff. So much new stuff. Wait, let me clear up my inventory.
So this program is, you wrote it, so it's not built in. Right?
It's not built in. It's not built in, no. Also, there's some water. But it's online. You can download it if you want. There's actually a neat new loot disk, which was contributed by Vexitas. It is basically a package manager. So this little one here, let me get a disk drive. Just show this off real quick. If it's done, should I cancel it? It's almost done. It's almost done.
Take this PC over here.
We could use the other one. That would be way too easy. That would be way too easy.
More than one computer in this world.
Yes. Anyway, so let's see. I think no. Oops. This should be in the path now. Yes. So this program, basically. Oh right, we need an internet card. Ta-da-da. Magic internet card. Where art thou? Da. Which needs tier 2, so we need to get a cheaper graphics card. Good. Let's try this again. Lots of text. So this is a package manager basically, and you can download programs from the interwebs, and you can get a list of all the different programs that people have already uploaded. So this is all hosted on GitHub. You can browse the sources yourself if you want, and there's quite a bit already. And as you can see here, there's also the program I ran on the other computer, the Geo2 Holo program, and a lot of more. And you could then basically just say, let's try this one. To install a program, it will download it, it will unpack it in the correct directories, and then you can just run programs. Isn't this fun? Oh god, what was the shape? Was it this way? I think, yes. And there you have Game of Life. Good. And the hologram is done. So I think I'll just make it night for the moment, so it's easier to see. Yeah. So this is basically a snapshot of the surroundings. You can kind of see the structure back there. And yeah. You can do nice things with this.
Remember, there might be some noise, so
yes,
not
exactly.
Everything you see here must be exactly as it's in
not
the
perfect.
real world.
Yeah, the real world. Yeah, so basically if you want a better representation of the hardnesses, just do multiple scans and get the average. Right, that's that. Good.
Okay, so...
so far so good.
Could you show how you can program the hologram projector? Because
sure.
I think we never showed that.
So it actually got a little easier since 1.2. So the API changed a bit, basically because now there are colors, and it would be way more difficult than before to get it work the way you want it. So if you remember 1.2, and if you try to have a look at it, if you didn't, anyway, what you had to do in 1.2 was you had to specify the columns as bit masks. So you had an integer, and every set bit in that integer was a set block, and every 0 was air. And what it was not bad. I mean, sure, you had to do some bit shifting and fun, but not that bad. But with colors, this will get kind of out of hand. So right now it's a little bit easier. So if I get the Lua shell up and have a look at the hologram component, the set function now takes, instead of 2 numbers, it takes 3 numbers, the coordinates of the voxel to set and the value of the voxel to set, which can be either Boolean for on or off, or it can even be the number, which is then the color. So we have a 3-color palette, which is per default green, red, and blue. So let's see, if I say component hologram set this, then there should be somewhere, oh no, wait, bottom top, I think. This way. Yep, there's this little voxel in the back here, which is the coordinate I just set. So the coordinate system is the world system of Minecraft. So the x-coordinate is the world x-coordinate of Minecraft, and the z-coordinate is the world z-coordinate of Minecraft. You cannot rotate the holograms. If you want to rotate what's displayed, you have to rotate it in software, basically, before you plot it to the hologram projector. And that's that. So one final note maybe, as you see, there's a function here, set palette color. What you can actually do is these 3 colors that are used for displaying the voxels can be changed. So let's see, palette color, the first one, let's set it to, so this is a hex value of RGB, so like you use it in web development or anything. And if you set that to, I think this is yellow. No, it isn't. No, it isn't. Oh, wait, hologram. Hologram. There we go. No, it's turquoise. Anyway, you see these red blocks now change to, what is blue? Blue, turquoise, whatever. Wait, then this should be yellow. Oh, right, green, blue, yes. Right, exactly. So you can set that to any color value you want. You just have 3 colors, but those colors can be any value you want them to be.
Okay, so first is that the color 1 is now this value. Okay.
Yeah, exactly. So it's index of the palette color and the value of the color to assign.
Mm-hmm.
And that's that. Oh, right. If you never worked with holograms before, there's also a scale setting, so you can make these bigger. Oops. I always forget the component name. It's terrible. Bam. So
I'm inside the hologram.
Now the hologram is a tad bigger, as you might see. Yeah. So that's also possible if you want bigger and better holograms. Or smaller ones. So you can fit it into 1 block space if you want. It's cute.
That's nice.
Yeah. It's like a miniature. It's nice. Yeah. I think that covers holograms pretty much. Let's see. Any other methods? Well, yeah, there are utility methods for copying and filling areas, but I think you can work these out yourself. It's not that difficult. And there's a wiki, so everything should be documented in the wiki by now. Yep. Okay. That's that. Good. Let's see. Have I forgotten anything? Items, right. There are new items. It never ends.
Okay, so, yeah. Will this fit in a new episode, or shall we do them now?
Whatever you want. I think it's 1, 2... Well, yeah, just some updates. I don't know. Whatever you like. We can split it afterwards.
I would say, yeah. we will see. Maybe we'll see you in the next episode, or maybe the video continues.
We will see. Okay, let's surprise people. Good.